Hi, my name is Vlad, and welcome to my YouTube channel. Today I'm going to do something a little different. I'm going to talk about my all-time favorite Lego set, which is the Titanic. This set is absolutely gorgeous. It's huge, it's very detailed, and it's quite accurate. And I'm going to do something a little different. I'm going to talk about my favorite topic of the Titanic, and that's the technical aspects, the technology of the Titanic. I, as a mechanical engineer, love the technology that the Titanic had, considering it's over 100, almost 110 years old. It's incredible. So that's what we're going to talk about today. So I'm going to start with the propulsion system, or the power generation plant. So what actually generated power on the Titanic? So the Titanic was a steamer. What that reference means is that it was powered by steam. Back then, over 100 years ago, man had pretty much mastered the art of steam and used it to power almost everything in that society, including the huge Titanic. So let's get into a little bit of detail on what produced that steam. So how is this energy generated? That was done by boilers. And what the boilers did is they would take water, they would turn it into steam at a pressure of 215 psi. If you're wondering what that means, is your car tires are inflated to about 35 psi, so it's about 7 to 8 times more pressure. And what powered the boilers was coal, and it was shoveled in manually into the boilers by what they called firemen back then. It was a very dirty and dangerous job. It was paid well, and they would basically have to shovel the coal continuously to maintain the power levels. Now, the Titanic had 24 double-ended boilers, which means you could shovel it from both sides, and 5 single-ended boilers. These boilers took up an area from about here to here, so from the first funnel to the third funnel, all in the lowest deck, which is right here, the lowest deck of the Titanic. Actually, Lego included some of the boilers. If you can see here in the cross section, it shows you 4 boilers right there. 4 of these boilers, which refer to the Scotch boilers. So that's what generated the power. Now, what was that power used for? Well, first thing it was used for, primarily, to power the ship, to make sure that the ship was propelled through the water. And the way that was done is through these reciprocating motors, 2 reciprocating motors, which were located near the back. Those reciprocating motors turned the propellers, each on one side of the 2 outer propellers, and they were piston driven. There was 4 pistons in it, and the steam basically went through the pistons and in what they call 3 stages, high, medium, low, and basically turned the crankshafts. And Lego has actually included those reciprocating motors, and actually what was really cool is that they made them actually turn, and it actually turns the propellers. So if I turn this one here, it actually turns the propeller and the pistons go up and down. Now it is a little bit simplified, but the general principle is the way it was. And these things were massive, so if I take one of them out here, they're truly really massive. They were 2 to 3 stories high, and they generated about 15,000 horsepower each, which is huge. That is a lot of power. Now, normally, that would be it. The steam would be in most ships. The steam then was condensed back into water, recycled back, heated again, turned into steam, and the cycle continued on and on and on. But in the Titanic was actually a little bit more fuel efficient. And what made it fuel efficient is that the remaining steam from the reciprocating motors was funneled through a turbine. A turbine is a cylinder, basically, with a that has a shaft, and it has a whole bunch of blades on the shaft. And as the steam goes through the blades, they turn the shaft, which turned the 3rd propeller, which was right here. What's really cool is Lego actually included the turbine, but you can't see it. It's actually located inside the body of the ship, the last section of the ship. But what's really cool is that they actually use gears to represent the turbine blades, and you could actually turn the blades by turning the propeller, which is really, really cool of Lego to do for us technical buffs, because you don't actually get to see that, and it's totally enclosed, so they didn't really have to do that. But it's really cool that they did, and I thank them for that. Way to go, Lego. Just one other note is only 3 funnels were used from the boilers. The 4th one was a dummy funnel. It was felt that the Titanic looked much more majestic with 4 funnels. So only these 3 were actively used to vent out the gases from the boilers. What's also really cool is that the ship had power steering. What I mean by that is that there was a steam engine that was used to pull the rudder in each direction because it was so massive and heavy. And who knew? The Titanic would have power steering before cars had power steering. How cool is that? So with all this power being generated, and you have 2 motors running at 15,000 horsepower, and the turbine added to about another 8,000 or 9,000 horsepower to that, you had a lot of horsepower running the ship. Now, with the final speed of the ship, it wasn't the fastest ship afloat, but it was definitely the biggest, and it could do 21 knots, which was really fairly decent speed at the time. There was enough coal on board for about 8 days, or equivalent to about 8,000 tons of coal. Now, what was really also cool is the way that the commands to the boilers to how much coal should be fed to the boiler was done. It was done by a telegraph system. And that means that there was a board that was fed by a telegraph system from the engine room that would have little slots that would open and say like full, stop, half, quarter. And that would give the foreman indications of how much coal needed to be shoveled into the boilers, how much steam needed to be produced for speed. So what else was all that power used for? Well, it was used to generate electricity. There were 2 dynos run by steam engines that generated electricity. That was pretty much more power than a power generation plant of a city that time. So it was a huge amount of power that was used to turn on all the lights, to keep the lights on. Some of the first class cabins had heaters and electrical plug-ins, and some of the other equipment. The steam was also used to heat the heated swimming pool, and also the Turkish baths. There was Turkish baths, to heat for the Turkish baths and to heat the rooms as well. So that's generally what it was used for. The Titanic also had 4 working elevators and a telephone, and some rooms had even telephones. Now, the other thing that was kind of really cool about the Titanic is it had the world's most powerfulest transmitter at that time, a powerful telegraph system. And that telegraph system, if you're wondering where the antenna was, if you go from this mast to this mast, the cable that runs along there was actually the antenna of the telegraph system. It could basically broadcast a radius of 350 miles out from each direction of the Titanic, which was fairly incredible at the time. State-of-the-art technology. The other thing that was really cool is that the Titanic, since it was an ocean-going vessel and it crossed many time zones, had a master-slave clock system, which meant is that the main master clock was at the bridge, and when they would set it, it set electronic pulses to the other clocks that were installed in the Titanic, and it would push the hands forward or backwards, depending on how it was set, to synchronize with the master clock. Now that is really cool. Now I also want to talk about one other thing, the fabrication of the hull. The Titanic was fabricated using steel plates and rivets. At that time, welding was a fairly new technology. It's very expensive and just not practical. So the way the Titanic was built is they took plates of steel and they would use little rivets and they would rivet it together through holes. And a rivet is basically like a nail. It's hammered in, but instead of screwing it in, it's basically forced into a hole, very hot, and then it's pounded from both sides. So when it shrinks, it basically pushes the plates together and creates a seal. There were millions of rivets on the Titanic. Now, this is one thing that the Lego creators didn't do. They didn't replicate the plates and all the rivets. Now, have they done that, this would have definitely been the world's largest set by part count, because there would be millions of little rivets and thousands of plates put together. But in all honesty, you'd have to use a tweezer and a magnifying glass to see the rivets, and putting those into the plates and putting it together would take just millions of hours of time, and even I don't have the patience for that. So maybe it's a good thing that they didn't do that, and that's okay, Lego. So lastly, what I want to talk about is basically, I'm not going to spend time talking about the sinking and the disaster because that's been very well documented and argued. But one thing I want to talk about is the technical aspects of the hull. And that is, when the Titanic sunk, it split into two parts. So why did it actually split? Some say that the material is inferior. I think that wasn't the case necessarily. At that time, the steel quality was as best as it could be for that time. Some say there was a coal fire that weakened the structure, and so forth and so forth. A lot of theories, but the best one that I like to think happened was that, first of all, few things. One thing is that the hull was compromised by the damage to the plates that was caused by the iceberg. Secondly, the Titanic, when it sunk, it filled with the front part filled with the compartments filled with water, so it would sink like this down. So when the back half came out, all the heavy motors, the reciprocating motors and all the machinery, everything, all the steel in the back, was a lot of strain on the hull. It was never designed to take that. And thirdly, and most importantly, is when it sunk, the front half was full of water and the back half was still full of air. So the front wanted to go down, was pulling the back down, and the back was resisting going down because it was still full of air. So it was a big tug of war between the hull, and with everything else going on, it basically snapped in half, and the front went down and the back end stayed up floating for a few more minutes before it sunk too. So generally, I think the design wasn't necessarily flawed. It was just too much stress in the hull, and that's what happened. So what I'm going to do is I'm going to try a little experiment, because no technical talk wouldn't be complete if we didn't do at least a little bit of a science experiment. So we're going to see how well this Titanic is built out of Lego, and how structurally integral it is. So we're going to kind of simulate the sinking. I'll show you what I mean by that. So I've never tried this before with this set, but I'm going to try it now, and hopefully it won't end up in a disaster. We're going to see how structural integrity the Lego set is and simulate the sinking. So what I'm going to do is I'm going to bring the model forward kind of to about the halfway point where roughly it was pivoting when it was sinking. And I'm going to grab the front of it. I'm going to let the back come up. And what I'm going to do is I'm going to tilt it, pivot it to simulate the sinking and having the front come up. And as you can see by this experiment, it's still in one piece. And even if I shake it, even if I put a little bit of pressure on it, it stays in one piece. So, interestingly enough, the Lego Titanic is built very well. So maybe if the Titanic was built out of Lego, it wouldn't have split in half. Well, probably would have, but one can only hope. So I hope you enjoyed that tour. I really enjoyed presenting that. I think Lego did an awesome job on representing the technical aspects of the Titanic. Really love that they put the motors, that they have the reciprocating motors and they turn the propellers. Showed some of the boilers. They have the antenna for the transmitter and some of the other cool stuff that was incorporated into the Titanic. So thumbs up, Lego, keep it up. Great work on the technical aspects. That's it for now. Have a great day. And if you really enjoyed this video, give it a thumbs up or subscribe, and we'll see you then.